Hi there, this is Professor Duresh, and this is the first video in a three-part video series on the initial concepts of factoring. So the two concepts we're going to be taking notes on are greatest common factor and factor by grouping. We're going to focus on three separate skills. So skill number one is going to be to find the GCF, or greatest common factor, of two or more expressions. Once we're familiar with identifying that greatest common factor, we then need to factor out the greatest common factor. And then finally, we're going to see how GCF factoring can be used to factor a polynomial with four terms by grouping. Factoring is the process of figuring out what two things were multiplied together. For example, if I give you the numerical expression 56 and I ask you to factor it, I'm asking you what two numbers are multiplied to produce 56. And in the case of a lot of numbers, composite numbers in particular, there's multiple answers that work. For example, I can get 56 by doing 7 times 8, or 14 times 4, or 28 times 2, or 56 times 1. These are all considered factor pairs of 56. If I instead say to factor something like this, a polynomial, your goal as the student is to figure out what things might have been multiplied to produce these two terms. Now, some examples include x times 2x plus 6. And you can check my work by distributing the x. Another example might be 2 times x squared plus 3x. And our goal for this lesson is actually the last one, which is 2x times x plus 3. This is the greatest common factor of the polynomial 2x squared plus 6x, so this is how I factor out a GCF. So let's take a look at two or more numbers and how to find their greatest common factor. And we're not going to do polynomials, we're going to do regular numbers. So example 1 is going to be to find the GCF of 18, 24, and 72. So we are looking for numbers that divide evenly into all three of these numbers. Those would be the common factors. Then we want to identify the greatest possible number that divides evenly into all three of these numbers. So let's take a look at the individual factors and see how they compare. The number 18 can be thought of as 2 times 9, or 3 times 6, or 1 times 18. If we break it down into its prime factorization, or its smallest factors, then we would get that 18 can be rewritten as 2 times 3 times 3. Because 2 times 9 breaks down to 3 and 3. We'd get this result from any of these factor pairs. If you take the same approach to 24, 24 could be 2 times 12, where 2 is the common factor. It could also be thought of as 3 times 8, 3 is the common factor, Or it could be 4 times 6. 4 is the common factor. It could also be 1 times 24, but 1 isn't going to be a greatest common factor, so we don't normally consider that pair. If you think of this as its prime factors, we can break down 4 to be 2 times 2, and we can break down 6 to be 2 times 3. These are the prime factors of 24. These are the smallest numbers that can be multiplied together to produce 24. 72 is going to be the most difficult because it's got a lot of factors. So with 72, I'm going to take a different approach. I'm not going to list everything that multiplies to be 72. I'm going to do a factor tree to find the prime factors that make 72. So 72, I know, is 6 times 12. 6 is 2 times 3. And 12 is 2 times 6. 2 is prime, 3 is prime, 2 is prime, but 6 breaks down to 2 and 3. So the prime factorization for 72 is all of the primes together. 2, 3, 2, 2, 3. And I'm going to organize these in ascending order. So I have 2, 2, 2, 3, 3. Now you may have noticed what the greatest common factor is, but let's take a look at these prime factorizations and find it here. All 3 numbers are divisible by 2. All 3 numbers are also divisible by 3. If you look, they don't have anything else in common in all 3. These two have a 3 in common, but this one does not. These two have a 2 in common, but this one does not. So the greatest common factor is 2 times 3, which is equal to 6. 6 is the largest number that can divide evenly into 18, 24, and 72. What does this look like when we're dealing with polynomials instead of numbers? So for example 2, we're going to find the GCF of 10x squared and 15x to the 6th. We're going to factor each coefficient into primes, and we're going to write the variables with the exponents expanded to find the common factors. So let's start with 10x squared. 10x squared can be rewritten as 2 times 5 times x times x. 15x to the 6 can be rewritten as 3 times 5 times x, 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 x. Now we're looking for the most that these two have in common. They both divide by 5, and they both have 2 or more x's. So the GCF is 5x squared. In the next video, we're actually going to start with this example, and we're going to talk about how we can use identifying the GCF to factor the polynomial and write it as the product of 2 polynomial expressions.